Welcome back to another edition of my blog. This is James Kelly. It's July 25th. This article is called "It's the End of Network Automation as We Know It, and I Feel Fine." And this article was originally posted on July 5th, actually, on the New Stack. You can visit the New Stack at thenewstack.io. You can visit the article directly because there's a direct link on my blog, the blog posted on jameskelly.net/blog. And of course, that means that I need to give a big thank you to the New Stack for posting it there first. As always, if you want to get access to these first, you can also just follow me on LinkedIn. All right, away we go. It's the end of network automation as we know it, and I feel fine. Network automation does not an automated network make. Today's network engineers are frequently guilty of two indulgences. First, random acts of automation hacking. Second, pursuing aspirational visions of networking grandeur, complete with their literary adornments like self-driving and intent-driven, without a plan or a healthy automation practice to take them there. Can a middle way be found, enabling engineers to set achievable goals while attaining the broader vision of automated networks as code? Taking some inspiration from our software engineering brethren doing DevOps, I believe so. How not to automate. Yeah, there's a phrase going around in our business: to err is human, to propagate errors massively at scale is automation. Automation is a great way for any organization to speed up bad practices and #fail even bigger. Unfortunately, when your business is network ops, the desire to be a cool ops kid with some dev chops as opposed to just a CLI jockey will quickly lead you down the automation road. That road might not lead you to those aspirational goals, although it certainly could expand your blast radius for failures. Before we further contemplate self-driving, intent-driven networking, and every other phrase that's all the rage today, although I'm just as guilty of such contemplation as anyone else at Juniper, we should take the time to define what we mean by proper in the phrase building an automated network properly. If you haven't guessed already, it's not about writing Python scripts. Programming is all well and good, but 20 minutes of design often really does save about 2 weeks of coding. In other words, to start hacking at a problem right away is probably the wrong approach. You need to step back from your goals, think about what gives them meaning, and apply those goals to the broader picture and plan accordingly. To see what's possible with automation, we should look at successful patterns of automation outside of networking and the reasons behind them, so we may avoid the known bad habits and the anti-patterns and sidestep those avoidable pitfalls. For well-tested patterns of automation, we needn't look any further than the wealth of knowledge and experience in the area of DevOps. Yes, it also matters what we call things. For better or worse, a name focuses the mind. The overall IT strategy to improve the speed, resilience, quality, and intelligence of our apps and our software is not called automation. It's not even called orchestration. Now, while ITIL volumes steadily make their march into the museums, the new strategy to enable business speed and smarts is incontrovertible, and it's called DevOps. Now, initially that term may invoke a blank page or even a transformation conundrum, but you can learn what it means to practice successful DevOps, culture, processes, design, tooling, and coding. DevOps can refine your approach to the network, and that's why we ought not promote network automation, which could focus the mind on the wrong objectives, and instead talk about DevNetOps as the application of patterns of DevOps applied to networking. Networks as code. The idea of infrastructure as code has been around for a while, but surprisingly has seldom been applied to networking. Juniper Networks, where I hang my hat, and other networking vendors like Apstra have made some efforts over the years to move folks in this direction, but there's still a lot of work to do. For example, Juniper has had virtual form factors of most series of hardware systems. They've had projects like Junosphere for network modeling in the cloud. Many of us now use Ravello. And impressive presentations on IAC and professional services consulting. Juniper's senior marketing director, Mike Bouchon, formerly with Plexi, wrote about the network as code even all the way back in 2014. IAC, or infrastructure as code, is generally well applied to cloud infrastructure, but it's way harder to apply to networking and things like bare metal. For evidence of this, just look at OOO, Kubernetes on Kubernetes, or Kubernetes on OpenStack on Kubernetes. Oh my. That bottom metal layer is quite the predicament. To me, this means in networking we should easily be applying IAC to software-defined networking, or SDN. But can we apply it to network devices and to manage the physical network? I asked Siri, and she said it was a trick question. As an armchair architect myself, I don't have all the answers, but as I see it, here are some under-considered aspects for designing networks as code with DevNetOps. 1. Tooling. In tech, everyone loves shiny objects, so let's start there. Few network operators, even those who have learned some programming, are knowledgeable about the ecosystem of DevOps tooling, and few consider applying those same tools to networking. The point is, learning Python and Ansible is really just scratching the surface. There's a vast swath of DevOps tools for CI/CD, site reliability engineering, and at-scale cloud-native ops. 2. Chain the tool chain, a pipeline as code. When we approach the network as code, we need to consider network elements and their configurations as building blocks, created in a code development pipeline of dev, test, staging, production phases. Stringing together this pipeline shouldn't be a manual process. It should be mostly coded to be automatic. Just as with software engineering, there are hardware and foundational software elements with network engineering, such as operating systems that the operator will not create themselves, but rather just configure and extend. So these configurations and extensions with their underlying dependencies can be built together, versioned, tested, and delivered. Thinking about the network as an exercise in development, automation should start in the development infrastructure itself. 3. Immutable infrastructure. Virtualization, and especially containers, have made the concept of baking images very accessible and immutable infrastructure popular. While there's still much work to do with network software disaggregation, containerization, and decoupling of services, there are many benefits of adopting immutable infrastructure that are equally applicable to networking. Today's network devices are really the poster children for config drift. But to call them snowflakes, well, that would be an insult to actual snowflakes. Applying principles of immutable infrastructure, I imagine a network where each device pixie boots into a minimal OS and runs signed microservice building blocks. Each device has declarative configs, decoupled secret management and rotation, and logging and other monitoring data, with good overall auditability and traceability, all of which is geared to take the network and its data off the box ASAP. Interestingly, practices such as SSHing into boxes would be rendered impossible, and practices that, quote, savvy network automators do today, like running Ansible playbooks against an inventory of devices, would be banished. You can only do that in maintenance windows. Anti-pattern. Number 4, upgrades. Upgrades to network software and even firmware microcode or devices could be managed automatically by means of canary tests and rolling upgrade patterns. To do this on a per box or per port basis or at finer levels of flows or traffic processing components, we need to be able to orchestrate traffic balancing and draining. If that sounds complex, it is slightly, we can make things simpler. We can treat devices and their traffic like cattle instead of pets, and then just rely on their resilience. Killing and then resurrecting a component would restart it, but with a new version. Now, while this is actually suitable for many and some software applications, treating traffic as disposable is not yet desirable for all network applications and SLAs. But still, it would go a long way toward properly designing for resilience. Which brings us to number 5, resilience. One implication of all of this is the presence of redundancy in the network paths. As with any networking component, that's very important for resilience. Drawing inspiration from scale-out architectures in DevOps and the microservices application model, redundancy and scale would go hand in hand by means of instance replication. So redundancy would neither be one-to-one nor active-passive. We should always be skeptical of architectures that include those anti-patterns. Good design would tolerate a veritable networking chaos monkey. Burning down network software. It would just circuit break to limit failures. Killing links and even boxes we would quickly reconverge, as we often do today. But dead boxes, dead SDN functions, or dead virtual network functions would act like Phoenix servers, rising back up, or staying down in the case of repeated failures or detected hardware failures. The pattern for preventing these black swan event failures is to practice forcing these failures, and thus practice automating around them so that the connectivity or other network service and its performance is tolerant and acceptably resilient on its own SLA measuring stick, whatever the meta service in question may be. Doing DevNetOps. In each one of these above topics lies much more complexity than I will dive headfirst into here. By introducing them here, my aim has been to demonstrate there are interesting patterns we may draw from, and some operators are doing so already. If you've ever heard the old Zen Buddhist koan of the sound of one hand clapping, that's the sound you're likely to hear from your own forehead once the obviousness of applying DevOps to DevNetOps in networking hits you squarely in the face. Just as the hardest part of adopting DevOps is often cited actually to be breaking off one manageable goal at a time and then focusing on just that, don't boil the ocean, I think we'll find the same is true of DevNetOps. Before we even get there in networking, I think we need to scope the transformation properly of applying DevNetOps to the challenges and design of networking, especially with issues of basic physical connectivity and transport. While, quotes, network automation leads the mind to jump to things like applying configuration management and programming today's manual tasks, don't jump. DevNetOps, it should remind us, in that word, that there is a larger scope than mere automation coding. And that scope includes culture, processes, design, and tools. Collectively, they may all lead us to a happier place. All right, that's it. Thanks again for tuning in. And remember, kids, always look both ways before crossing the automation avenue.